Well, good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for the event, and I welcome you. We have a great webinar on tap today, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will be able to access the webinar on demand following. You'll be receiving a link via email that will take you to the webinar on demand. And we are taking questions from the audience. So if you have a question for our panelists at any time during the event, please use your GoToWebinar control panel, submit your questions, and we should take some time, probably about 15-20 minutes near the end of the presentation, and go through the audience questions. Okay, with that, we'll go ahead and get started with the webinar, which is Know What's in Your Containers. Manage and secure all open source that composes your containers. Our speaker today is Dave Muir, Alliance's Technical Manager at Black Duck by Synopsys. Hi, Dave. Welcome to the webinar.
Thanks, Charlene. Happy to be here. Thanks, everyone, for joining.
Excellent. Well, I'm going to go ahead and turn it over to you and let you do your thing.
All righty, great. Yeah, so as Charlene mentioned, I'm Dave Muir, work for Black Duck by Synopsys on our business development team, primarily focusing on our strategic partner integrations. I started at Synopsys through the Black Duck acquisition, which occurred late last year, where I was at for about 7 years, working with the prospects, customers, and partners in the area of open source software management. So I wanted to start the webinar with a look at the different security tools that come into play when you think about containers. The first tool that typically is run during development are static analysis tools. So these are tools that would scan the actual developer's code, the proprietary code, and list potential vulnerabilities like SQL injection. Then there are tools called software composition tools. Software composition tools look at what is brought into that application that is not proprietary. Typically, that's open source, and help you understand things like vulnerabilities associated with those open source components, the licensing that's associated with community or project statistics like committers and contributors. And then the third category is dynamic analysis or sort of runtime tools that can take a look at your running application and see if you are exploitable or can prevent access to your running applications or containers. Some of these tools, as you look in the market, might seem to overlap each other, but if you take a closer look, you might notice that they are either OEMing other tools or partnering with other tools as well. So for example, there's static analysis tools that we partner with that use our software composition analysis, and there's dynamic tools as well that OEM other SCA tools. But today we're going to talk about SCA, and that's the category that Black Duck is in. But as you look at these, at the security tool landscape, it is a little bit fragmented or siloed, and that's one of the reasons why Synopsys acquired Black Duck, along with other tools in these categories over the past 4 years. Synopsys is obviously known for being the market leader in electronic design automation, but they saw a need to ensure the quality and security of softwares in chip design. And through several acquisitions, they've evolved the business unit to become the market leader, ensuring quality and security in all application and containers for our customers. So if we go and take a look at exactly what that middle piece was, software composition analysis, it's basically understanding the contents or for example, the operating system components, the application packages that compose that container. And as most applications and containers these days consist mostly of open source software, we'll talk more about that later, it becomes extremely important to have intelligence about that open source software that compose your containers. But it's important not just to have intelligence on some of the open source software, but all of it. So the operating system layer, the app layer, if you're interested in understanding if there's snippets of open source. You want to know everything about that open source software, the packages, the licensing, the vulnerabilities, but also down to the version, because the version is very important when understanding vulnerabilities. And also, if you think about in the case of Linux distributions, you want to know which distribution this is coming from, because, for example, the great folks at Red Hat do a lot of patching, backporting. So you don't want to be inundated with all these vulnerabilities of a Linux distribution when Red Hat has already done patching for you. Now, I wanted to mention that applications in containers are comprised mostly of open source software. So just to validate that, I wanted to take a look at Black Duck's annual report that was just published a couple months ago on the state of open source. And we can see that it's no surprise that 96% of these applications contain open source. But actually, for the first time this year, the average percentage of open source software in code bases is over 50%. So 57%, that was up from last year, which was a third of the code bases that we analyzed. This is basically saying that more applications, more containers have open source software than proprietary code. And if you think about a Java application, for example, with jars and what you bring in, obviously that becomes a larger part of your code base than the code that you write. And obviously with more open source comes more vulnerabilities. As you can see, 134% more vulnerabilities were found this year than last year, and 54% of those were categorized in the high vulnerability range. But also, if old vulnerabilities aren't going away, as you can see, 17% still contained well-known vulnerabilities such as Heartbleed, Freak, Drown, Poodle that were publicized about 4 or 5 years ago. And then we see that 8% of these applications actually had Apache Struts, and a third of those applications still have the Apache Struts well-documented vulnerability that we'll actually discuss here in a minute. So it's no surprise that security breaches are a problem, and having open source intelligence will help reduce the cost of security breaches and lost business, but having it by itself really isn't good enough. As shown here, it takes over 6 months to identify and contain a breach. And so the key goal with Black Duck and Synopsys and our great partner Red Hat is to provide this open source intelligence to our customers as quickly as possible to solve this problem and reduce the response time for security breaches. So I wanted to take you through a real world example with one of my favorite components, which is Apache Struts. Last year, around this time, March 6th, which was a Monday, a vulnerability was reported by a security researcher, which is common within open source vulnerabilities. They're typically found by humans and not by tooling. Now, a responsible security researcher would typically go through what's called an embargo process. So before they release the vulnerability information publicly, they work with the open source project, community, or company to come up with a patch and then announce that. And so March 6th was the end of that embargo process. The patch was available, and this vulnerability was publicized in the media. Another non-unique characteristic of vulnerabilities is that this bug was introduced in the code 5 years earlier in an earlier version, version 2.3.5, but it took 5 years and a responsible security researcher to actually find it. Now on March 2nd, the day after, a public exploit was published, meaning anybody with an internet connection could download code and run it against various servers to see if those servers were exploited or not. This vulnerability affected the Canadian Tax Agency. So on March 10th, which was a Friday, they actually had to shut their site down, which was their tax return submission site. That same day that vulnerability was reported by the National Vulnerability Database, CVE 2017-5638. CVE stands for Common Vulnerabilities and Exposures. And that's actually pretty quick for the National Vulnerability Database to publish details within a week. Usually on average, they're about 3 weeks delayed to get details out. But it was a high profile vulnerability, and the CRA actually realized within that week that attackers were breaching their systems with this public exploit. So they had to shut their site down, which was a big deal to these guys because a month and a half later, taxes were due, and I believe they gave an extension last year, but obviously they had to have their developers working over the weekend and everybody all hands on deck to get that vulnerability resolved. So that was just a week's time frame. If you remember, the average is about 6 months. Well, coincidentally, 4 months later, this is the same vulnerability that affected Equifax. Now, 4 months is still better than average than 6 months, but obviously it was too late, as the CRA and Equifax and others found out that breachers are hitting sites as soon as vulnerabilities are published. So that at Black Duck, with our partnership with Red Hat, we aim to shorten that life cycle. We try to get vulnerability information out to our customers within 24 to 48 hours so they can make informed decisions on how to remediate. This all starts with having a knowledge base of open source intelligence. So the Black Duck knowledge base, we've been collecting the data since the inception of the company, over 14 years. We've got the largest dedicated team to the knowledge base that spans 3 different teams. We've got a core team, a team looking at machine learning and enhanced or AI technologies to further enhance the quality of the knowledge base. And then we have a dedicated security research team with about 16 security professionals monitoring over 100 different security sites daily. They also have robust tooling to help triage these vulnerabilities to get enhanced vulnerability data out to our customers. Vulnerabilities are published about 15, or if there's 15 vulnerabilities published per day. So it's not a 1 or 2 person job. You need a team of security professionals with tooling to understand these vulnerabilities and process them. Another key aspect with the Black Duck knowledge base is the amount of sources that we are monitoring. So you can see over 10,000 different sources. GitHub.com is one source. Red Hat errata data actually is another source. And so anything that is open source, we want associated in the Black Duck knowledge base. And that allows us to support many different programming languages. So you can see we have support for 80 different programming languages. I didn't even know there was 80 programming languages out there, but there's apparently a lot more. We can support scanning and identifying open source components. So it's basically the infinity of open source that exists. The database is pretty large these days. It's over a petabyte of data that we've been able to collect. Now, this knowledge base is part of an architecture within Black Duck that's sort of a hybrid architecture. So you see the knowledge base there on the right-hand side that is hosted typically by Black Duck. One of the benefits of Black Duck hosting it is that we are updating that knowledge base on an hourly basis. So I mentioned 15 vulnerabilities come out per day. Our security researchers are processing and triaging those vulnerabilities, coming up with possible fixes and workarounds, technical data, and pushing that information to the knowledge base within 24 to 48 hours. Every hour is a batch update. We don't store any customer data in the knowledge base. It's really just a lookup type of event that occurs when a scan is run. So on the left-hand side, you can see hub detect scan. The scan at its core is a command line tool where you can point it at a folder or a file or an archive file. And that scan will traverse those files and folders, create signature information, as well as inspect package management information, and send that encrypted information through a hub web application up to the knowledge base to do matching. Once those hashes and signatures are matched, the identified open source components will then be reported on a web application that is dedicated for each customer. So usually that web application is installed on-prem. Its architecture is containers, so it can absolutely be installed on OpenShift or on a VM, or you can use our marketplace deployments on AWS, Azure, or GCP. Now the hub web application contains all the results of scans, all the information that Black Duck provides that we'll see here in the demo shortly. But there's more to Black Duck than just the Black Duck UI in the knowledge base. We want to make sure that all the information that you need is in the tools that you use. So here's a list of a lot of our integrations. By far the most popular integrations are the CI layer, because that is typically where all of the components that are going to consist of your application are pulled in to then create that build output, for example. And that's where you would want to scan. You would want to scan both the source code and the dependencies to get a complete and accurate list of open source components. You can use our integrations in IDEs. For example, we have Eclipse integrations, we have Visual Studio integrations, we have a nice Chrome plugin, as well as you're searching open source sites. For example, the Maven repository, we can tell you if this version that you're looking at has vulnerabilities. Or you can move right into the SDLC or the DevOps lifecycle here to use our integrations like OpenShift. So if we take a look at the Black Duck OpenShift integration, it can be summarized in this statement. It's basically the ability to automatically scan and monitor the third-party open source and all container images in OpenShift. So let me dissect that statement for a minute here. Black Duck is in what we call a native integration within OpenShift. We're tied into the OpenShift APIs, the image API and the pod API as well. And we're actually a containerized project in OpenShift. We monitor the components that are scanned, identified, and found. So you don't have to rescan an image every time a new vulnerability is published. Black Duck is monitoring those. I mentioned every hour we're publishing new vulnerabilities. And if any of those new vulnerabilities affects the images or the components that are in those images, then we will alert you. We also look at the third-party open source. So you may be wondering, Red Hat does a great job of curating their own open source, their RHEL images. and help you understand, and back patch these open source components. Black Duck can look at everything else as well. So the open source that your developers bring in, the open source that may be just a file and not managed by a package manager, or maybe your developers are bringing in images, God forbid, from another registry that aren't rel based. So Black Duck can take care of all of those as well, to help you understand security, licensing, and other items. The other part of the sentence that is important is the word all container images. So all, regardless of the image source or registry. So for example, you can bring in images into an OpenShift environment through GCP, if that's your registry, or AWS, or if you have an Artifactory repository. Any registry source, we will be able to capture that event and scan that container image. And then finally, it's important to note that Black Duck is an SCA tool. It's looking at the container image, the contents of that container image itself. We're not looking at the running container, that would be the runtime category. We're looking at what's composed of that image. And from a technical standpoint, we're basically doing a Docker save, which results in a tar file, and scanning that tar file, that archive file, and all the layers within it. So to take a look at the architecture in a little bit more in depth, this is a high-level view of an OpenShift architecture with a master and one-to-many worker nodes. OpenShift obviously has an integrated registry, or you can pull in images from external registries, as I mentioned previously. We talked about the Black Duck knowledge base that's typically hosted in Black Duck's data center, feeding information, or actually Black Duck web application, the hub, is pulling information from the knowledge base, and that can be installed within OpenShift as well. And then the integration itself, when you install it, it installs its own namespace, becomes a project within OpenShift, and installs about 4 or 5 different containers based on the options you choose to interact with OpenShift and the Black Duck hub. So you can see 2 containers here, the image processor and pod processor. They're both tied to their respective APIs within OpenShift. This is a very microservices module with a lot of modules that you can change out if you want to use some other types of processing or other custom functionality. There is a core container that's in charge of communicating with the containers of the integration, Black Duck offsite integration, and the Black Duck hub, as well as communicating with the scanner container when any events occur within the image API, image stream API, pod creation APIs. So you see there's actually 2 images, 2 containers within the scanner container. One is a scanning container that wraps that scan client, which I talked about in the architecture diagram previously, to run the actual scans. And then there's an image getter, which actually does the Docker save command to create that tar file and puts it in a directory for the scanner container to run the scan. Now, the image getter does have elevated privileges, but it is a separate module. So you absolutely have the freedom to customize and create your own sort of image getter container to grab the contents of a container or to grab the image. In another way, maybe you want to pull it from CI/CD for the scanner to go and scan that image. But when a scan occurs, the results are sent in those fingerprints or SHAs to Black Duck, and through the knowledge base, matches occur, and then results are sent back into the Black Duck offsite integration. And the integration is labeling and annotating images and pods within OpenShift. And I'll show you what that looks like when we get into the demo. There's another default container that you can install within the offsite integration. And as Ducky here tells me that a new vulnerability has occurred, we'll re-annotate labels and annotations. The core piece is actually pinging the Black Duck server every 30 minutes to get new vulnerability information. And then, yeah, any new policy violations or vulnerabilities will be labeled or annotated within OpenShift. So the last piece here in the architecture is that optional Prometheus master I was about to get to. The Prometheus, as some of you may know, is just a UI for metrics gathering, but you can use your own metrics capability. We're basically publishing metrics, all sorts of core metrics from the Black Duck offsite integration to certain ports, and Prometheus is then capturing those. So this is what we call the offsite integration. That's the Black Duck integration with OpenShift that automatically scans and monitors all container images regardless of source. Now you might be thinking, how does this relate to OpenSCAP? And there's actually a blog that Red Hat did about a year or so ago where both OpenSCAP and Black Duck were featured, and it talks about the complementary nature of both products. OpenSCAP is more on the running container and can help you with your running container policies, where Black Duck does more of the deep container inspection. There is a little bit of overlap with Red Hat curated content, but as we've mentioned before, Black Duck would look at the infinity of open source, all the remaining open source that composes your applications and your containers. All right. So let's go to a demo. And to start the demo, I just want to give you a quick overview and some concepts of Black Duck. The first thing that you would see when you log in is a list of projects. Projects is a generic term because when you scan, you can actually scan for applications, you can scan single files, or you can scan container images. This is a list of container images that were automatically scanned in an OpenShift environment. But each of these projects can actually contain multiple versions. So if I go into this Node.js one, you can have multiple versions here. And then those versions would contain a list of open source components that were found down to the version and down to the distribution. And the other metadata, like the license associated with this open source component, the security risks, so the number of known security vulnerabilities, and an aggregation of certain metadata to give you three categories of risk: security risk, license risk, and operational risk. Now, security risk is pretty straightforward. It's just the count of components that have high, medium, or low vulnerabilities. License risk is actually a combination of the license that are found associated with these components and how you're distributing this container image, whether it's external distribution, think about things like cell phones or routers or even cars, or is this an internal distributed application? You're only using it for internal purposes, or is this SaaS-based? All of those different distribution models have different risks associated with them when you're thinking about open source licensing. Then there's operational risks. Operational risks has a couple different factors. One is how old this version is, how many newer versions exist, and then the health of the project. What's the commit and contributor count over the last 12 months? You can see this one has 2 contributors, which may cause companies concerns in terms of, if a vulnerability does occur, will those 2 developers support this community and patch it quickly? This is just a high-level view of a list of components. You can absolutely dive into the details. So for example, if we go into the security tab, this will show me all the components that have security vulnerabilities and a list of those specific vulnerabilities themselves. So one of the things I mentioned is that Black Duck listens to the Red Hat errata data. And in this case, we're looking at the GNU-C library, which is highlighted down here. And you can see that Red Hat has patched all of these vulnerabilities. So there's over 50 known vulnerabilities, and these were the status of these vulnerabilities were automatically patched. So you don't have to worry about this. This is obviously a CentOS image, but if it was a Red Hat image, you'd see the same thing here as well. But you can absolutely go into these vulnerabilities and understand things like what is the, from a CVE standpoint, let's take a quick look. What's the description? What's the rating that it provides? And then the National Vulnerability Database provides things like common weakness scoring. So this is what you get from the National Vulnerability Database. Not very actionable. Let's take a look at Apache Struts here. And what I'm doing now is actually searching. This is hitting the knowledge base, so you actually don't have to scan components to understand what vulnerabilities exist, what licenses exist as well. So if we take a look at, let's look at one of my favorite ones here. Let's go to 2.3.15. And you see no results found because I haven't actually used this version in any of the images that I've scanned. But if I take a look at the security vulnerabilities, you'll see a combination here of CVEs and Black Duck security advisories. So BDSA is Black Duck security advisory. And when I open up the details, you'll notice compared to the National Vulnerability Database, Black Duck security advisories provide a little bit more actionable data. So how to fix it? What version fixes this? And what was the patch that actually fixed this as well? So you can see there's the actual GitHub pull request that fixed this version, this vulnerability. What's the workaround if you can't fix it right away? And then we provide our own scoring, our own 2.0 and 3.0 CVSS scoring, as well as our own temporal metrics. And we typically look at the CWE to see if it was categorized properly, meaning maybe there's more specific CWE that makes sense. And we also add things like technical details to help you understand the vulnerability more, things, advisories, vendor upgrade links, the exploit if it exists. So a lot of good information to help you decide and how to act on this vulnerability. Now you might have seen that earlier page that we were looking at. This Black Duck can also be a tool to help developers be proactive. This information as you're working through IDEs can be, we have an integration with certain IDEs that can show you, hey, you're about to use version 2.5.33. It has some high vulnerabilities. You might want to look at something like 2.5.16 that currently has no vulnerabilities. So that's a quick view of a component list, a result of a scan, and some of the data that you would see after a scan occurs. Now, another concept to understand with Black Duck is policy management. Policy management allows you to create policy rules based on one or more conditions. So for example, project condition or component conditions. I can add, project tier equals my top priority projects, add a condition about components. I can create policies on blacklisted components here, blacklisted license. And when those policies are assessed, then, as you can see here, policy violations occur on the components that are identified, automatically identified in those scans. This puts this image, this container image, at a failed policy state. So if I take a look at all the policy, all the violations, the Morgan component 190 for some reason is in my blacklisted policy components. So I can see that, this is my blacklisted component. And that puts this image in a failure state. So remember that as we go back into OpenShift and look how that data manifests itself within the pods and images. So there's a lot more to Black Duck than what I just showed. But at this point, I want to take you back into OpenShift and show you how the integration works. So if we take a look at OpenShift Container Platform, I have a Black Duck offsite project that was automatically created during the installation process. So you notice here's some resources that relate to the containers we were talking about earlier, the core container, the two processors, and the two containers that compose the scanner resource. Here's my optional Prometheus application. And so, for example, here's a look at when I installed this version of Black Duck within OpenShift. This is a graph that shows the current status of the images being scanned. This red line are scan completes, and so you can see it worked its way up and finally finished and equaled the number of images that were found within the OpenShift environment, which is 148. There's some other lines here that are important. This is the actual scan, running scans. So the scan runs and then it destroys the container when it's done. There's a lot of more interesting statistics as well that you can go through within our Prometheus master. Things like, what pods have vulnerabilities, what images have vulnerabilities, what images have policy violations as well. But once the integration is installed, it'll identify all of the images. It'll start scanning all of those images automatically, and then it'll sit idle. And once, whenever an image is created within OpenShift or a pod is created, it will check to see if it's scanned that image already, and if not, it will run through the scanning process. It typically takes on average around 3 to 5 minutes. If the scans are taking longer, then you might want to look at tuning and horizontally scaling some of your Black Duck job runner resources. So if we take a look at an example application, if I look at my Ducky demo, you can see I've got a Cake PHP example as well as the Node.js example. This Node.js is exactly the same one that we were looking at previously at the hub here. So this is the Node.js example that I created. And once the scan is completed, the integration then annotates and labels both images and pods. So if we take a look at the pods in one of the Node.js pods, you'll see that there's some Black Duck software labels and images out here in the pod. Now there can be multiple containers per pod, so you might have multiple labels here. But you can see some of these things that say, for example, does this image have policy violations? Well, it's true, because this image had that Morgan component that was in violation. How many components have policy violations? Just one. And then it goes into the vulnerability descriptions as well. How many components have vulnerabilities? 17, and if this pod and if this image has vulnerabilities. The pods and images are also annotated. So you can see, for example, the annotations. We actually worked with Red Hat on this structure, this JSON structure, to come up with a policy and a vulnerability structure to properly annotate these pods and images. These are obviously accessible through the command line. So if I move over to my command line, you might, let me actually clear this out and move up here. So you can see an OC describe command. I'm describing the images with a label that have policy violations. This will return to me all the images in my project that do have those black duck policy violations. So if I go up here, you can see those labels in this actual image itself. So this is where you can use these image labels or these annotations to further manipulate or control your images. I've seen some CI/CD pipelines that test for these annotations and only will promote images to another environment, like your staging or production environment, if they pass policy or if they don't have any vulnerabilities. So that's where you would automate and use these labels to affect images within an OpenShift environment. So that's basically it in terms of the integration. Again, I go back to the architecture and just a quick review. Whenever images are created, updated, modified, introduced into your OpenShift environment, created as a pod from any source, the Black Duck offsite integration will capture those events and scan them. And then the results of those scans from a security risk and policy management capability will be annotated and labeled within your pods and images. All right. So I believe that is it from a presentation and demonstration perspective. I appreciate everyone attending, and I'm going to pass it over to Charlene to go through any questions.
Excellent, excellent. Thanks very much, Dave. Yes, it is time for the questions. So if you do have a question for Dave, please go ahead and use your control panel, and we'll take a look at the questions that have come in so far. We do have one from Yarek who asks, is there an inspect profile for this?
That's a good question. I'm not sure I understand the question actually. An inspect profile.
Inspect profile, yeah.
Yeah, I'm gonna write that down, and I can try to get the answer.
Okay. He just sent over a link, GitHub inspect, github.com/inspect/inspect. So you can do a little bit of background research and then get back in touch with them, I guess, unless you want to look it up real quick.
Appreciate it. Yeah. So I guess the answer to that is no.
Okay.
Yeah, I will. I'll definitely take a look at that. I'm opening it up now.
Excellent, excellent.
But yeah, thank you.
Yeah. So Yarek would love to hear from you and find out what you say. But the next question actually just came through from Adrian. Is the solution a subscription-based solution?
Yeah, it's a great question. So it is subscription-based. And just to give you a high-level view on the pricing, we do price on nodes, similar to how Red Hat prices as well.
Okay. All right, great. Okay, so if you have a question for Dave, go ahead and use your control panel. Yarek and Adrian so far have been the only ones submitting the questions. So Yarek, as we've discussed, I know Dave's gonna check up on the inspec and get back in touch with you directly to answer your question. While we're waiting to see if any more questions come through, we do have, I do want to remind the audience that today's event has been recorded. So if you miss any or all of the event, you'll be able to listen to it on demand. Okay, we just got another question in from Lady, and I apologize if I mispronounced your name. Does Black Duck support Ubuntu as well?
We do, yes, absolutely. So we have Ubuntu distribution sourced components in our knowledge base. Yeah, great question.
All right, yeah. All right, great. So as I said before, the webinar is going to be available on demand, but it's also going to be located on the DevOps.com website. So if you receive the link and it doesn't work, or you lose the link or whatever, you can always just go to the devops.com website and check it out there. It'll be listed under the webinars section on the site. We have lots and lots of webinars there that are upcoming and on demand, so you can check it out there. Let's see. Next question is from Adrian. He says, I might have missed some of the talk, but I am interested in if it works with containers only, or does it work with KVM and LXCs?
At this point, the integration only works with containers at the moment.
Okay. All right. And the next question is from Nayan. Does it support Windows container vulnerability?
So we don't have support for Windows containers yet, although I'm sure we will in the future. However, if a Windows container is basically an archive file, like a zip, then we can absolutely scan that file and inspect the contents of that Windows container. And so if there's any open source components within the Windows container, we can absolutely identify those and understand the vulnerabilities there.
Excellent. Okay, great. So we'll wait just another minute or so, see if we get any more audience questions in. But I do want to thank everybody who have submitted questions so far. They've been good ones, and I'm sure that Dave's got a little bit of homework to do, judging from some of the answers so far. So that's good for him, I guess. But looks like that is pretty much going to be the end of the audience questions. So Dave, I'm going to give you some time back in your day, which is great, at least for me. I hope it is for you as well. It was a great presentation. Thanks very much. And it really interesting. I love watching the demos. They're always so much fun to watch. So I'm sure the audience got as much out of it as I did. So thank you very much for giving such a great presentation. And I do want to thank the audience also for joining us today. And if you do have any other questions, you feel free to circle back with us, and we'll make sure that the connections are made between you. Actually, before we go, Adrian just sent in another quick question. Do you have information on the support of containers on the website somewhere publicly that he can access?
Yes, actually, we have a partner page with Red Hat. So if you go to blackducksoftware.com/partners, you'll see Red Hat there, and we've got a bunch. We've actually have a video and some data sheets that you can grab on about containers.
Excellent. Excellent. All right. Well, that was probably the best question we could have had to close it out. So again, Dave, I do want to thank you for your time today, for giving such a great presentation. It was really, really interesting. So thanks very much. And thank you again, audience, for joining us today. And I hope everybody has a great day. This is Charlene O'Hanlon. I'm signing off.
Thank you. Bye.